Hey, workshop students, let me do a first video of this year, a solution video. Here is one about, so I guess it's about really a rate and a unit conversion. Let me put here area per time. But the real point of the problem here is unit conversion. It's really not so much about the rainforest. It's about converting units. And there's a couple of ways, or a couple of things to talk about. Let me show you two ways of converting units. I'll go the direction that your instructor does, and probably most people do, but I will also add to this and show you something a little different that I think is a little bit better. And maybe I'll even do the solution both ways. I would say there's two ways also to do the solution. So if this video goes a little long, I apologize, but I hope it'll be good for you because there really are two different ways to do this problem. And maybe more, but at least two different ways that come to my mind, and I'll show you both. And there's also then two ways to convert units, and I'll mention both. Let me start with what I would probably call the most common way to do the problem and the most common way to convert the unit. So it might be a little different than your instructor's solutions here. But let me just begin by reminding you from your math class or any kind of discussion in terms of numbers of what is meant by rate. Rate would be a certain amount per time. So this could be like the rate at which you get paid. Maybe you get paid $15 per hour. Maybe this rate is, how quickly you are moving in a vehicle. So maybe this is 45 miles per hour. All right. So it's whatever amount we're talking about divided by whatever time we're talking about. And the units then, we need to kind of work out here. Because things like, well, let me just go 60 miles per hour because that's kind of an easy one to do, would actually be the same as 1 mile per minute. So the distance and the time kind of go together, and these are kind of the same rates. All right, so that's kind of a little review on rates. So on this particular problem, since the question here is asking for time, let's see, where's it? Here it goes. At this rate, a section of rainforest with an area of AS, being that of a soccer field, is destroyed in time of T field. So I think the point of this problem is to find this, T field. I think this could be better written with some kind of question here, but clearly, but the way it's set up, this is the idea, is to find this unknown time. So let me kind of rearrange this. Let me put time over on this side of the equation, and then take amount and divide it by rate, okay? And so amount divided by rate is how we're going to get time. Now, the amount, they make it very clear, the amount is a soccer field. Okay, so this is 7,190 square meters, according to this problem. And let me be careful here, because I see the way your instructor has this set up. This might actually be a number that changes for every individual. So I'm going to use the one who asked this question to make this video, and they're using this number. But my warning for some of you, you might have a different number out there. In fact, let me think about this. Let's see. A soccer field is usually, what, like 120 yards by, 60 yards. Oh, that's yards. And that's about 120 square yards. And a meter's a little smaller than that. All right, well, let me not get bogged down in converting it. But, okay, that seems like a very near number. to square meters. Okay, since a square yard is a little smaller than a square meter. Okay, but let me stay focused on the problem here. All right, so here's the amount. Okay, that's the soccer field. And then here's the rate. And so they give here the AR being the rate. So one thing that could be a little challenging, I know it was for me, is learning how to read this question. This I had to read it about 7 times before I finally figured out that they're given numbers here. They're not in the problem. They're asking a question, but it doesn't have a question mark, and it's over here. So maybe that's something I can help you with also, is just the way the questions are not written in a traditional question format. So it took me a while to kind of understand what was being asked, but I think I got it now. Okay, so the rate here, and here it is, AR, looks like it's 10,465 square kilometers per year. Now, I would say, sadly, this does not show per year in it. I don't know if that was intentional or not. But that's the way I read this. Now I'm beginning to question if I'm doing it right here. So I might end up deleting this and starting all over. But I think that's right. I think that's just a little typo or a misnotation because it says this is the amount destroyed per year. So maybe you don't need the per year there to make it clear, because it's very clear in the question that this is the rate per year. But in my equation, I need to put that as per year. Okay, so now I can continue on with the math. Now, there's a phrase I want to share with you, and one that I like to say is whatever you do mathematically, I call it the rules of mathematics. So whatever you do with your numbers, also do with your units. And I say that because you guys are well along in your education and working with numbers. Not so much with your units. When you've had a math class ever since, first grade, you've worked a lot with numbers, but not always so much your units. That's more of a science thing. And you probably did a little bit of that, in different, levels, maybe a little bit of grade school, a little bit of middle school, a little bit of high school, maybe even a lot in high school, but more so than ever now as you are getting into your science level. So I'm going to say this. Let me just write it. And again, I hope I don't bore too many of you. As the way I say it, treat your numbers and your units in the same way. All right. And so I'm going to put my numbers together and I'm going to put my units together. Okay, so if I put my numbers together, I could just simply take 7,190 and divide it by the 10,465, and I get 0.687, and that's the number. So that's probably the easier part of this problem. And then let me look at the units. And so the units would be, and here's where I'm going to say, follow the same rules of mathematics. So when I have a compound fraction, I flip and multiply. So let me write this as such. Okay? Now, there's the flipping of the denominator. But the other rules of mathematics, if you have something on the top and something on the bottom, they cancel each other. So, like a 5 over a 5 cancel, and it's just 1. An A over an A cancels, and it's just 1. So it's nice to get the same units here, okay? And we don't quite have that, okay? So now we get into the unit conversion, because clearly both of these are measuring areas. So we just need to convert our square meters into either square kilometers, or we need to convert our square kilometers into our square meters. Why don't I do, since the unit conversion, the two ways I said I would show you, Let me do the most common one first. So again, this I think is the most common way to solve this problem, and I don't think that's the way he did it. So I should talk about the way he did it. Your author or your instructor here. Looks like he did a ratio, and that's fine. But I think this is probably a more common way. So I'm going to do the most common way. And let me convert the unit, which I think is the more common way. And it's usually something along this line. Let me go to the top of the paper here and just write 1,000 meters is equal to 1 kilometer. Now, what that would mean then mathematically is if we divided both sides by 1,000 meters, this side, which is 1,000 meters over 1,000 meters, the number would cancel and the units would cancel, and you would get 1. So what this is saying mathematically is a kilometer over a meter is equal to the number 1. That's why it is perfectly legitimate to multiply by this ratio. You don't change anything when you multiply by 1. And so this is my justification that that is equal to 1. So most people, when they do their unit conversion, do this. They realize that if you put something in the numerator and something in the denominator that is equal, then this is just multiplying by 1, and you're not really changing anything, and therefore the justification of why you can do it. Okay, now here's the reason why you would do it and how you would pick it. You see, if I'm trying to get rid of a meter in the top, that would cancel with the meter in the bottom. So that's why I set it up with meters in the bottom, looking ahead. Because I could have easily had written this as 1,000 meters over 1 kilometer. But if I had put that into here, I wouldn't get the meters canceling off. So either one of these ratios is equal to 1. And so either ratio I can use right in here to multiply. I just need to pick the correct one. So what I like to say is, pick a ratio that's equal to 1 that's appropriate to get rid of it. Now, I'm not quite there yet, but you can see that I have a meter squared, not just a meter. So let me square this whole thing. Because remember, if this is equal to 1, if you square it, it is still equal to 1. Now this gets me somewhere. So here I have the meters squared, and if you'll just let me drop the 1 over here, and then I have year, and then over here I have kilometers squared. Then over here, this square, and again, maybe I need to take you back to your mathematics a little bit, but remember, if you had xy squared, that would mean you have x squared and you have y squared. And so, again, work with your units in the same way you would with your numbers. I said that earlier, and I'm going to keep saying that. The same rules that you do in mathematics for your numbers, do that for your units. So this would be x squared and y squared. So that means here in this numerator, this would be the number 1 squared, but it would also be kilometers squared. And then down here would be the number 1,000 squared, and it would also be a meters squared. And of course, now hopefully you can see why I picked that ratio, and why I squared it was because then now meters squared in the top cancels with meters squared in the bottom, and kilometers squared in the top cancels with kilometers squared in the bottom, and then down here the only unit I'm left with is the unit of time of 1 year. Which, remember, back here at the beginning, this was an equation that's supposed to give us an amount of time. So it's a good thing that the units all canceled out and gave me a unit of time. In this case, years. Which, by the way, means I have more to do because I see that this says it wants the time in seconds. So I got more unit conversion to do. But at least I've gotten it to the point of a year. Now, again, let me say that I should put all my numbers together. All right, so I still have this number in my calculator, the 0.687. Let me divide that then by 1,000 squared. And I won't multiply by a 1. That's a waste of time. Okay, and just hit enter. So this would be 6.87 times 10 to the negative 7 of a year. Now, like I said, technically we've answered the question about time in a year, but we're not done with the problem because we need to go on and do some more unit conversion. Okay, so following that pattern, again, the most common pattern is to find a ratio where the stuff in the top and the stuff in the bottom are equal, because that way we know the ratio is equal to 1. That was my comment back here. Okay, so I'm going to do the same thing, but I'm going to do it with time. And I know this. I know that 365 days is equal to 1 year. So again, notice I'm multiplying by 1. Notice that the value in the numerator, 365 days, is the same as the value in the denominator. So I don't change anything. That's why back here when I multiplied by 1, I didn't change anything. And the same thing here, I'm not changing anything. This technically is the answer, but it's not simplified, you know. And everything from this place forward, I'm going to just multiply by 1. Converting the unit. So here I did it to get rid of all the kilometers and meters to get it into years, but now I'm going to do this, and you can see I set it up deliberately so year was in the bottom because I knew year was in the top, so year would cancel with year. And so this is going to give me an answer in days. And I'm debating if I should calculate it or just keep going. I'll just keep going with the same logic. Because if I multiplied this out, this would tell me how many days. What I also know, though, is there are 24 hours in a day. So let me say it again. Notice how the numerator and the denominator are equal to each other. So that means this ratio here is equal to 1. And so again, I'm not changing anything. There's my justification where I can just magically multiply by it. But I picked a appropriate one so that days were on the bottom to cancel off with days on the top, and then I would be left with hours. So if I multiplied all this out, I would now have my answer in hours. And again, although I'm tempted to do it, let me do 2 more steps, because I also know that there are 60 minutes in an hour. So again, notice these are equal, so I'm just multiplying by 1. And I just only moved this down here because I just ran out of room on my sheet of paper. Okay, so think of this right next to it like that. Okay, but that means the hours would cancel off. And if I multiply it all out, I would have how many minutes. And then one more time, 60 seconds in 1 minute. And maybe I better use the common notation, S for seconds. And then, of course, minutes would cancel off. So I'll say it again. Notice every time I'm multiplying by something, I'm actually multiplying by 1. So I'm not going to change my answer. What I do change is the units that represent my answer. All right, so grabbing my calculator, I already got this number in here. So if I go times 365, that would be converting it to the number of days. Then multiplying that by the 24, that would convert it to the number of hours. Then multiplying that, by 60. And then finally one more 60. And if I've done all this right, we are at 21.7 seconds. And that's the idea of converting the units. I suppose I should say something about the significant figures. Generally, in a physics class, we're not quite as focused on them as they are in a chemistry class. So if you've gone through chemistry, you will know that they will pound you hard for the right significant figures. We have decided to let the chemistry program push that and help you with those. They are important, and then sometimes we get lazy with them. That almost conveys that we don't think they're important, but we do think they're important. We just don't dwell too much on it. And so we usually work with 3 unless otherwise specified. But in this problem, if you count them, 1, 2, 3, there's 3 significant figures here. I think that's just a placeholder. And then 1, 2, 3, 4, 5 here. And our answer should be the same as the minimum number, which is 3. So I'm going to put 3 here in my final answer. And so if these were the numbers that you all had, again, I don't know if they change or not, but looks like I got the 21.7 seconds would be the time here. Okay. Now, I said there are other ways to convert units. So if you want to leave this video, I completely understand. But if you want to hang for a second, let me show you the second way that might be useful to convert unit. Let me come back up to maybe this step right here before I multiply by that 1 right there. So let me write down 0.687, and then we have a meters squared, we have a year, we have a kilometer squared. All right, so that's back to this step where I started doing these multiplication by ones, which, like I said, is the more common and I think the easier to understand. So if you're struggling with this in any way, probably stick to that. That's the easiest way to understand. And hopefully you understand the justification of how it works, as well as the knowing which way to order the units. Do you put kilometers on top of meters, or do you put meters on top of kilometers? So hopefully that helped illustrate that. But I find this, although it's a little more advanced, more useful. And let's start with this kilometer. Many people think that the km stands for kilometer, and that's not quite true. It's K for the kilo and M for the meter. So when you put it together, it's km. Now, I know you might be thinking, well, isn't that the same thing? No, not at all. Because kilo means 1,000. So when you write km, what you could easily convert that to is 1,000 meters. Because it's not km for kilometer, it's K for 1,000 and M for meters. So that means right over here, I could have taken, I think, an easier, albeit maybe more sophisticated approach on my conversion of kilometers by just putting, what does a kilometer mean? It means 1,000 meters, and I can square it. And when I do that, I'm not doing this, although as you guys can probably see, this is the equivalent of that. So they're the same thing. But I think it's a little more advanced way of thinking about what do we mean by our units here. And so when I put that in here, 0.687, and I divide it then by 1,000. And like I said earlier in the video, this would be 1,000 squared. So 1,000 squared. I get that 6.87 times 10 to the minus 7. And then the meters squared drops off right away, and then years. And so, again, you can decide if you like that better versus just multiplying it by this. And so it's kind of easy to see this. And so I kind of like that. So I like this for the beginning students, and I like this for the advanced students. Ideally, you would be able to kind of comprehend both, I guess, is what I'm after. All right. So notice that that's the same number I got right here when I did this, before I started converting the years into days. Well, let me continue with this logic, because all I really did is what I'm going to call a substitution method. See, I call this the fraction or the multiply by 1 method, and I call this the substitution method. Because if I did this, I'll come to the top of my paper here. If I said 5x equals what? And then I told you x is equal to 3. Well, you would do a substitution. You would say, well, there's 5, and then times the x would be times 3, and so that's 15. And so you directly substitute in the meaning of x. And that's what I did here. This is why I call it the substitution method. I directly substituted in what a kilometer means. Or, yeah, not what a kilometer means, what a kilo means. A kilo means 1,000, and then a meter. So I just directly substituted it in. Now, here's why I say that. Because remember this, that 1 year is 365 days. So what I could do right here, I call it direct substitution, is in place of a year, and I'll say it again, whatever rules of mathematics you do for your numbers, here's your numbers, you could also do with your units, and you should do with your units. And so 1 year is 365 days. So I can just directly, and year is gone, and I have it now units and days. And notice that would be the same thing as this step, where I've taken the time to cross out the years and get left with days, and I would just have my rate number and then the 365. And I can do that all along. Well, what is a day equal to? Well, direct substitution. A day is equal to 24 hours. What's an hour equal to? Direct substitution. 60 minutes. Well, what is a minute equal to? 60 seconds. So notice I'm substituting in for the unit each time. So the year becomes a day, the day becomes an hour, the hour becomes a minute, and the minute becomes a second. Now notice also I'm substituting in for the unit only, not the number. So this means this number times that number times that number times that number times that number, which notice is really the same math that we did here. We're just not directly putting the units over each other and canceling them. All we're doing is substituting them out. So it's a little bit faster, maybe a little bit harder to understand. And that's why I said maybe this is best for the beginning students, and this is better for those of you who are maybe a little more advanced, or as maybe next semester comes along here. All right, so if I take that number and then multiply, we'll just see if we got the same thing. 365 times 24 times 60 times another 60. We should hopefully get the 21.7, and sure enough we do. And so there's my 21.7. So again, for those of you who continued on past the answer, hopefully that was enlightening for you. But I would say, again, 2 ways to do the units: the multiply by 1 or the direct substitution, whichever you like, and ideally both would be in there. Now, I also said there were 2 ways to do this problem, and so I did it a way different than the instructor has it here. So let me jump back to what I would say is a less common way, but certainly a valid way. And then he looks like he does his unit conversion by multiplying by 1. Okay. So let me say what is he doing, in case you're curious. He's doing something a little different. He's saying this, that instead of what I did, rate equals amount divided by time, he's saying something like I did here. A rate in big units would be the same as a rate in little units. So, if you're talking about the rate at which you get paid after a month, so, how much did you get paid over the whole month? That rate is the same as how much you get paid per hour. And so, keeping that in mind, he does this. He says, if you take the area of the soccer field and divide it by the time for the field to diminish, that would be the same as the area lost in 1 year. Okay, so these are the same rates. Okay, and just here you're thinking about a big amount over a big time, And here you're thinking about a small amount over a small time. Whichever way you want to do it. I guess maybe density is a good example. If you took a chocolate bar, the whole chocolate bar, so the mass of the whole chocolate bar, if you do density of chocolate, the mass of the whole chocolate bar divided by the size of the whole chocolate bar would be the same as the mass of a little square divided by the area of that little square. All right. Because this problem then gives you the area of the soccer field. So this is this 7,109 D. And then this gives us the time of the field. And then over here, this would be the area destroyed of the forest in a year. So there's the area. Oh, and I forgot my unit. Sorry about that. That would be square meters, but this would be square kilometers. And then this would be a year. So now if you manipulate your math around and you bring the time over to this side, so time field, and you bring this over to here, this is this 7,190 square meters, and I can divide it by, and I'll just bring the whole thing in one shot, the 10,465 square kilometers per year. This is now the same as the way I approached it here, which I would say is the more common way. And then the rest of this is exactly the same as this. And so that's what's going on right here as he finishes up the problem. Okay. Now, I hope that helped. I noticed there is a second question to this. So maybe just for completeness, I'll continue on and answer this second question. And it looks like it's looking for the area of the soccer field if it was destroyed in 23.9 seconds. Now, remember, we got 21.7 seconds for a soccer field of 7,190. So keep in mind that this is a little more time than the problem above it. So our area is going to be a little bit more than a soccer field, although not all soccer fields are the same. So this might be the time for a big soccer field. This is actually already a pretty big soccer field. So I would say, I don't know about most, many soccer fields are smaller than that. Yeah. And of course they're measured in yards, not in meters, because they go way, way back. But before the metric system was even invented, so it's an old game. Okay, so why don't I go ahead and at least finish up, if anybody's still paying attention to this long video, and I'll go back to the, I guess I'll call it the more common way. You can, I guess, debate, but I'm going to put rate is equal to amount over time, and then come to this question and see that they give me the rate. Oh, I need to be careful. I said it would be a bigger area, but that's not necessarily true. This is the rate smaller. So the rate's smaller and the time's longer. Maybe this is designed to come out to be the same. Let's see what happens. Okay. So this is a smaller rate than before and a longer time. All right, so they give me the rates. Okay. So I'll put the rate as 10,147 kilometers squared per year. And the amount is what we're looking for. So there would be that number, the area of the soccer field. And the time is the 23.9 seconds. Okay. So, as I said, let's just follow the rules of algebra. I'll bring this to the other side. So this would be 10,147 kilometers squared, 23.9 seconds over 1 year, and it doesn't matter, I guess, where I put them. Probably should have put it over here. It might look better to you. Okay, that's over 1. Okay, so there's where I'm going to get it. Obviously, the units of seconds need to cancel off with the units of years to do my unit conversion. So why don't I do my unit conversion? I guess I'm kind of debating how to do it. Should I do a multiply by 1 or direct substitution? Well, if you hung with me this long in the video, why don't I do direct substitution? So direct substitution, I would put here 1,000 meters and square it. I would leave this alone at 23.9 seconds. And downstairs, I would put what a year is equal to, which is 365 days. And then I'd say, well, no, I'll just substitute what a day is. A day is a day is 24 hours. Well, no, an hour is equal to 60 minutes. No, direct substitute. A minute is equal to 60 seconds. And so I would get seconds in the bottom and seconds in the top, and then square meters, then a bunch of numbers to mess with. And so that's what makes it harder, messing with all these numbers. So across the top, I got 10,147 times, and I've got the number 1,000. Now remember, it's squared, so squared. And then times the 23.9. Okay, so that's the top. Then divided by, and let me multiply all these together, 365, 24, 60, and 60. And so this would be an area of 7,690 square meters, coming out to be the area of a soccer field. And again, I would think that's a little big. But nonetheless, I think also, as I said earlier, be cautioned with this. I think these numbers vary a little bit from person to person. And so whomever question I'm answering it because this is the numbers they sent me. All right, well, there's a lot more I could say about unit conversion, but in due time I will. This is probably a good place to end a 37-minute video. All right, take care, guys.